Hello everybody, welcome back to our electrical materials video. Let's get right into it with some more parts. To start with, we talked about wire that is going to be enclosed or concealed in a wall or in other spaces in a structure. What do we do if we're not hiding or concealing that wire? We need to protect it. We're going to do that with a material we call conduit. Conduit can come in a lot of different forms, shapes, and sizes. We're going to start with rigid conduit, and rigid conduit is available in metal or plastic. I've got a couple examples of a 3/4 conduit here. We would run our cables through these conduit, and then it would protect that cable from anything that would happen to it, whether that would be fasteners or just wear and tear or exposure to weather even. So you see here, this is 3/4 metal EMT conduit and 3/4 outdoor. This is a PVC conduit, and they're the same size inside. This is an inside diameter measurement. Keep in mind, conduit is going to come in long lengths. The metal version we can bend by hand, and the plastic version we're going to have to use different fittings to get it to follow a certain path. Conduit sizes are going to range anywhere from 3/4 up to 6 inches. They can even be larger if we're looking at commercial installations and some industrial situations. And the inside of the conduit cannot be completely full with our conductors. We need to only fill this inside space of this conduit up to 40%. The other 60% needs to be airspace. We need those conductors to breathe. They need to dissipate heat, so we need to leave some space in there. Another type of conduit other than rigid conduit would be flexible conduit. This conduit is going to take whatever shape or direction we want to put it in, and it's going to allow some flex. So we can run our conductors through this conduit. This type is also weatherproof, so it's going to be, they call it liquid tight. When you put special ends on this conduit, it's going to keep all the weather out. This conduit is also, like the rigid plastic, is going to be UV resistant. So this can be exposed to sunlight and be out in the elements. There's a whole array of different type of pieces and parts we will use to terminate the ends of the conduit into a junction box to a specific device. Those parts are going to look different depending on the type of conduit we're using and the material that conduit's made out of. Here you see some examples, and on the presentation there are some duplicates of these examples. The rigid type, the one at the bottom right, is for an EMT conduit. That's going to be for the metal pipe. It has a set screw. We're going to tighten that screw up to clamp it to the pipe. That's going to terminate the conduit. We can then run our cables through it. There's also, on a typical end for this kind of conduit, it's going to have a threaded end, and the end's either going to get threaded into the box or it would go through a knockout in the box. Then we would put a nut on the end to secure it to the box. This is a 90-degree turn for a liquid tight connection. We take our flexible conduit, we would attach it to the end of this piece here. That's going to seal up this end. Then this end would terminate in a box, and it also has this same nut on the end. If you look close also, it has an O-ring. This is a rubber O-ring that is going to allow that fitting to seal up against the box. That's what makes it liquid tight. There's a lot of other variations of hardware, some to make turns with EMT rigid conduit, some would be a coupler like the top right. That would be to connect two straight pieces together. It has the same set screws that we talked about before, and the one on the bottom is a version of a 90-degree turn we could use with a PVC rigid conduit. Now that we have our conduit run in the path that we need, we have to secure that conduit to make sure that all of this holds together. Just like our cables and our wire staples, these straps are going to hold that conduit tight. You might see a 2-hole version or a 1-hole version. The only difference is going to be the amount of fasteners we use to secure them. An armored cable is a type of a flexible conduit, and this cable has a wrap of aluminum around the conductors that are already inside of it. As you can see, I have some limited flexibility in this cable based on the way it's made. And the cables or the conductors on the inside are very well protected. This is a very strong type of cable. This serves as your wires and your conduit at the same time. So we have a typical 14 gauge setup here with our two conductors and our ground. As you can see, our ground is a green wire. So this has an insulation around it that's very common, and we consider green for ground. We have our black, which is our hot, and then we have our white, which is our neutral. Armored cable, or what they call MC, which is metal clad cable, is going to take its own special fittings. So if we wanted to terminate the end of this cable into a box, we'd use something similar to this that looks like our other hardware. It has this same set nut on it, and we can screw this into the box, or we can add the nut to clamp it to the box. This is the way these go on. You're going to thread these in around your conductors, and this is going to actually thread into the cable where you've cut it. It's going to thread nice and tight. Now we have a good termination of an end. This fitting is also going to protect the insulation of these wires from this very sharp edge that we cut off of this armored cable. Another version of cable you might see that's very similar to Romex but has a very different characteristic to it is an outdoor cable, or UF. This would be an underground feeder. That's the UF designation. This cable has a special jacket around it that is molded around the conductors that are inside. Same gauge wire, same insulation around the inside conductors. It's just that it is a more weather resistant and more watertight situation. This type of cable can actually be buried in the ground as long as the ends or bare ends of the cable are protected and dealt with properly. Moving on from our conduit and our cables, we're going to get into devices. We've run all of the system of conductors. Now we need to put them to use. My first device to show you is going to be a duplex receptacle. We're all very familiar with this. This is what we use when we're trying to get power out of an electrical system. This is a three-pronged outlet. You might hear it called an outlet. I call it a duplex receptacle because it has two plugs available on it. It has a three-prong arrangement, which is going to have a narrow blade, that's going to be our hot conductor. It's going to have a wider blade, that's our neutral conductor. It's also going to have a ground prong, that's the more round one. This is a modern addition to an outlet. You might see an older one that only has two prongs. It will be missing this ground. And on this receptacle, if we look at the side of it, it's going to have gold terminals. These terminals are going to accept a wire end, and as we curve that wire end, we can hook it on that terminal. We will then tighten it up. That's what's going to deliver our electricity to this outlet. So we have on this side, we have our gold terminals. That's where our hot wire or our black wire is going to go. On the other side, we have silver terminals. That's where our white wire is going to connect. And then we also have a ground terminal. That's where our bare ground or our green insulated ground conductor will connect. Next up, we have receptacles available to us that have safety features built into them. Just like the breakers we talked about earlier, we have a ground fault circuit interrupter outlet, and we also have an arc fault circuit interrupter outlet. This ground fault, they look very similar. You would not even know the difference unless you look very closely. What's different is the interior circuitry of them and how they operate and what they're looking for in the circuit. Very sophisticated circuitry in them. A ground fault is looking for current variations in the amount of current that's coming into them and the amount of current that's going out of them. If it senses an imbalance in those two directions of current, it will turn this outlet off immediately. That's a safety feature that could save you from electrical shock. These both versions of these will have a reset button on them. So if they trip, and often they can trip for reasons other than a person being shocked. It's looking for this condition, and if it trips, it will turn off. The reset button will reset power to this. It's important to mention that if this outlet is continually tripping, it might have gone bad, or you might have a problem with your wiring. So at that point, we need to look into this situation further. There is also a diagnostic feature on this device, which is a test feature. When you push the test button, it's going to test the system to make sure this device is working properly. You should do that every once in a while if you have these installed in your home. A quick review of the terminals on this device would be that the gold ones are for our hot or black wire. And then on the other side, we have our silver terminals. Those are for our neutral wire. It also will have a ground terminal. That's going to be green. That's for our bare copper or our green insulated wire. Here is our arc fault circuit interrupter, a whole different device, and what it's looking for is problems in the circuit, mainly for differences and problems with resistance, which in an electrical circuit equates to loose connections that could cause a fire. So this particular one is monitoring for that condition. If it sees or senses that condition, it's going to turn the power off instantly. It has the same test and reset features that our ground fault did. Next up, we have a simple device we're going to call a switch. Often we need to control other devices, and we'd use this device to do it. It's a simple on-off switch. We're all very familiar with it, and it works very simply. Let me explain that. So this particular switch is supposed to be, or we understand it to be, oriented so that on is up and down is off. That is the position we would mount this switch in when we installed this device. It also has fewer terminals than a typical duplex receptacle. So if we look at the right side of this single pole switch, you're going to see two terminals. They're both gold. We can connect a hot wire to either one of these, and I have a diagram to show you how that works. So here we have a switch and we have a simple light. We're going to run one wire in on one gold terminal, that's going to be a black wire, and one wire out, also a black wire, to our fixture or our light. When we power up that first wire, it's going to send voltage or current to our switch. With the switch turned off, the light does not receive that energy. When we switch that switch on, it's going to connect these two terminals, and it's going to let that electricity flow through to the light. So when we turn it back off, we're breaking the connection between those two terminals. That is the most simple version of a switch that we have. We also have more complicated versions of switches. This is an example of a three-way switch. The name's a little confusing. A three-way switch allows us to have two different switches for one location. So if this was switch number one, we could also have switch number two, and they would both control the same light fixture or series of light fixture. This is a convenience feature that allows us to put these switches in two different locations, possibly at two different entrances to the same room. There's a lot more complicated wiring that has to happen to make a three-way switch work, but I'll go through the basics of it. The difference between a three-way switch and a single pole switch is that you're going to have your two gold terminals, but you're also going to have a black terminal. And your feed wire, which is either feeding energy in or letting the energy out of the circuit, is going to come in or out from this black terminal. The other ones we call travelers, these gold ones, and they're going to give us two different paths for the circuit to follow. We'll get more into that when we get into the skills exercise about three-way switches. I would like to mention also that it has a ground terminal that would be for our bare wire or a green insulated conductor. To wrap things up with our electrical installation, we need to give all of our systems a finished look. We're going to use cover plates to do that. And a cover plate is going to do two things. It's going to make this whole electrical system look finished. So any point that we're touching or come in contact with is going to look good. The other thing that a cover plate does is it's going to insulate us from the potential of shock or any of those bare wires inside of that junction box behind that device. It's also going to, if there's any kind of fire or arcing in that junction box, it's going to help prevent fire from spreading from that location. So I have here some very basic low-end cover plates. Cover plates can get very expensive and decorative. They all pretty much do the same thing, and even your most basic cover plate is going to have to meet a UL listed criteria that keeps you, the user, safe. When we're talking about cover plates, we're talking about aesthetics. When we get to this point in the installation, we want to make this job look good. A lot of the aesthetics of the job or quality of the job is installing these properly. So you need these to be straight on the wall. You need to make sure that the screws are in place and that they match the cover plate that they're being used with, and that there are no bows or warping to the cover plate that cause a problem when you're looking at it. Let's do a review of our electrical materials. To start with, these are aluminum stranded heavy-duty conductors we're going to call service wires. Every building will have a meter base and a meter installed. This is going to allow us to measure the amount of energy coming in so that the utility company can bill the customer. A load center or service panel is going to contain all of the beginnings of the circuits. It will also hold all of the breakers that we're going to use to service those circuits. A circuit breaker is a switch and also has a safety feature built into it that's going to allow us to monitor the amount of amperage that's going through a circuit. Special safety breakers might be ground fault or arc fault circuit interrupters. These offer extra safety features. Romex wire comes in different gauges. It's also color coded and has different amounts or numbers of conductors in it. Wire staples are used to hold Romex to framing. We're going to secure it within every 12 inches of a box and every 54 inches everywhere else. Junction boxes are enclosures that are going to hold wire splices, any ends. It's also going to allow us a place to install our devices. Duplex receptacles are point of use plugs that we use to power our appliances. There's going to be 3 conductors or 3 prongs for the plug. That's a ground, a hot, and a neutral. AFCIs and GFCIs, which are arc fault and ground fault circuit interrupters, are safety versions of our duplex outlet. These are going to measure and they're going to monitor the current flow and resistance of the electricity, and they're going to shut off if we have any problems in the circuit. Single pole switches are simple switches we use to control one fixture or multiple fixtures in one location, and 3-way switches are going to allow us to have 2 switches that operate a single or multiple fixtures from 2 different locations. Wire nuts are special clamps that are twisted onto wire ends that are spliced together to help hold them tightly. Cover plates are used to finish off a device in a junction box to look good and also to keep the user from getting shocked and also to contain any fire that might happen inside that junction box. This is a list of terms used when we're talking about electricity. And as always, I like to stress this idea of learning the language of building and using it on the job site, especially when we're talking about skilled trades like electrical. So I hope you've learned something about some basic parts that are used in a residential structure when we're installing an electrical system. Keep in mind, there is an entire world of other parts and variations of all these parts that you will see when you get further into this trade. So I hope you've learned something. Get further into this. I'll see you in the next video. This video is a production of Trade Skills U, all rights reserved.